This project demonstrates how to build a complete code quality and analysis pipeline for a larger multi-service system using a multi-language Monorepo architecture. It supports multi-backend service, PHP, Go, Python, and a Node.js frontend. All managed within a single repository for better organization and scalability. The main goal is to perform automated code analysis across all service and unifies the result into one consistent view. Each module is tested independently, generating coverage reports in different formats, which are then normalized and merged into a single unified report. The pipeline integrates SonarQube Enterprise filter to analyze code quality, detect bugs, and vulnerability, and enforce standard 2 quality gate. It also reports brand analysis and pull request declaration to ensure code quality before merging. Additionally, the project includes code coverage tracking and technical data monitoring, providing a practical example of building a scalable DevSecOps pipeline for complete multi-language system. Flow explanation. This project demonstrates a complete CI/CD pipeline designed for a multi-language Monorepo system. The goal is to ensure high code quality, consistent testing, and automated deployment across multiple services. 1. Developer workflow. The process begins when a developer writes code and pushes change to the repository. Once the code is pushed, GitHub automatically triggers the CI/CD pipeline using GitHub action. This ensures that every change is validated before being deployed to production. 2. Multi-language testing. In the first stage of the pipeline, each service is tested independently based on its programming language. PHP generates a coverage XML file using PHPUnit. Go generates a coverage R file. Python produces a coverage XML file. Node.js generates an L-code info file using Jest. At this point, each module has its own test result and coverage report, but they are in different formats. 3. Normalized coverage format. Since each language produces coverage data differently, the next step is to standardize this format. Go coverage is converted into coverage XML file. Node.js keeps the L coverage info format. PHP and Python coverage reports are already in the correct format. This normalization step ensures that all coverage data can be processed consistently in later stages. 4. Merge coverage reports. After normalization, all coverage reports are combined into a single unified file called Coverage Combiner XML file. This unified report provides a complete view of that coverage across all services in the system, instead of treating each service separately. 5. SonarQube Unified Analysis. Next, the pipeline runs a SonarQube scan. At this stage, SonarQube performs two important tasks. First, it analyzes the socket of on service to detect code smells, bugs, security vulnerability. Second, it imports the unified coverage report to measure that coverage across the entire system. This combined analysis allows teams to understand not only code quality but also how well the code is detected. 6. Quality gate evaluation. After the analysis is complete, SonarQube evaluates the result using a quality gate. If all conditions are met, such as minimum coverage, no critical bursts, and acceptable code quality, the pipeline passes. If any condition fails, the pipeline stops immediately. This step acts as a control mechanism to prevent low-quality code from moving forward. 7. Docker build and image management. If the quality gate passes, the pipeline continues by building the Docker image. The image is touched using the commit SAA, ensuring scalability between the code and the deployed version. After building, the image is pushed to Docker Hub, making it available for development. A. Deployment to EC2. In the final stage, the application is deployed to an EC2 instance. The server pulls the latest Docker image and runs the application. This deployment process can be done via SSAs or automated script. Final result. At the end of the pipeline, the application is successfully deployed to production. This entire process ensures that all code is set across multiple languages. Coverage is unified and clearly measured. Code quality is enforced through SonarQube. Only high-quality code is deployed. Demo flow. In the first step, an EC2 instance is created to host the SonarQube server with at least 4 GB RAM and proper security configuration port 22 and 9000. Docker and Docker Composer are installed, and SonarQube is deployed together with Progress SQL using a Docker Composer file. After starting the service, user can access SonarQube UI, log in, generate a token, and configure a quality gauge with rules such as coverage, thresholds, and burst limit. In the second step, another EC2 instance is prepared for application deployment. Docker is installed, and port 80 is open to expose the application. In the third step, necessary secrets are configured. In GitHub include SonarQube Creator, Docker Hub Creator, and EC2 SSI information. Finally, when the code changes are pushed to the main branch, GitHub action automatically executes the pipeline. The process includes testing, code analysis, quality validation, Docker image build and push, and deployment to EC2. The entire workflow can be monitored in the GitHub Action tab, providing a complete end-to-end CI/CD demonstration.